This is going to be a short video about the difference of two squares. This is a factoring method. It's effectively just kind of a shortcut method. It is called the difference of two squares because those are the requirements for this factoring to work. You have to have two terms. There needs to be a difference, an aka subtraction between them, and they both need to square root perfectly, which is something that squared numbers can do. So difference of two squares, two terms, subtraction, square root perfectly. That's the why we have that name. So for a couple examples here, if we look at x squared plus 9 to begin with, this would be an example of something that you cannot factor using the difference of two squares. There are two terms, and they are both squares, but it's addition between them. And if all three requirements aren't satisfied, this will not work. Now if we look at x squared minus 9, now I have two terms and subtraction between them, and they do both square root perfectly. So what we do for our difference of two squares is we go ahead and find those square roots, the square root of x squared being x, the square root of 9 being 3. And literally all we do is have a plus version and a minus version, meaning you would get x plus 3 and x minus 3. Now there is a reasoning for why this works, because if you want to think about x squared minus 9 as a trinomial, we would write that as x squared plus 0x minus 9. Right, that is the same thing because 0 times anything is 0, so 0x is the same as just not having one there. So if we wanted to factor this using the x method then, with this being a trinomial, we could look at this as having an a value of 1, a c value of negative 9, and a b value of 0. So a times c, 1 times negative 9 would be negative 9. B value of 0 would mean we are looking for two numbers that multiply to negative 9 but add to 0. Well, that would be 3 and negative 3, right? 3 times negative 3 is negative 9. 3 plus negative 3 is 0. And so you see there is a reason why this difference of squares works. Where the real usefulness of difference of squares comes from is not necessarily here, because here, while what we did was less work, it's not that much less work than just doing the x method. What it's really useful for is if I give you an example like this. We've got x squared y squared minus 16z squared. Now technically there is a way that we could set this up to have this work for an x method, but it would seem very complicated if I did it that way. Not impossible, but certainly would look complicated. However, if we look at this in terms of difference of two squares, you'll notice that we have one term right here, x squared y squared, and another term right here, 16z squared. There is subtraction between them, and so if they square root perfectly, if both terms square root perfectly, we'll be good to go here. Sorry, I don't know why my screen just jumped like that. We'll be good to go here. So, I'll take my first term and square root. The square root of x squared is x. The square root of y squared is y. Square root my second term. The square root of 16 is 4. The square root of z squared is z. So I'll have xy plus 4z, and I will have xy minus 4z, and that's my answer, which is much easier than what we would have done if we'd had to do the x method.